Welcome to lecture 5.5. Here we're going to focus on Newman projections of butane, which is a commonly tested molecule in my experience. Now, butane is a 4-carbon molecule, and it also has 4 different rotational isomers to know. So what we'll do is I've drawn the first rotational isomer here, and we'll take turns rotating the front atom 60 degrees while leaving the back the same. So you can see here that we have the same back atom orientation, and we'll rotate the front atom to one by one reveal the 4 different isomers. Now, importantly, we're going to name these molecules, as well, or more specifically, name the isomers. We'll go through the different types of strain, either if there's torsional strain or steric strain, and based on that, we're going to rank the isomers, from 1 being the most stable to 4 being the least stable. So, to get started, here we have the most stable conformation of butane. Now, the key thing to pay attention to is that we have these bulky methyl groups attached, and as we discussed in the last lecture, these are quite large, and this orientation puts them as far apart as possible, so there's going to be no steric strain. Also important is the torsional strain is also not present, as the bonds are staggered instead of being eclipsed. As such, this is the number 1 most stable conformation here, and we're going to call this anti-staggered. So this name kind of makes sense. The bonds are staggered, and the methyl groups are on the opposite side of the structure, which is another word to say that is they're anti to each other. So the methyl groups are anti, and it's staggered. This is the anti-staggered conformation, or rotational state. Now, to continue on, let's go ahead and rotate this methyl group 60 degrees to the left here. That means that this hydrogen is also going to move, and so will this one. Remember that we're keeping everything connected to the back circle, so all these bonds are staying the same, and we're only moving things connected to the front carbon, rotating 1 carbon to rotate the bond. So with that in mind, our new methyl group location is eclipsing with this hydrogen. And we have hydrogens eclipsing here and here. So with this new state, we can look and we can say that there is certainly torsional strain. Right? So the torsional strain is present. So that's not a good thing, right? With sterics as well, we also see that these methyl groups are now really close to these hydrogens. So we also have some steric strain as well. This really isn't that good of a situation here. Now, the name of this conformation is partially eclipsed. Now, don't be confused here. This is an eclipsed conformation. It's not on the way to being eclipsed. But we say partially because it's going to get a lot worse. Right now, the bonds are eclipsing, but the methyl groups are still pretty far away from each other. If those methyl groups were to eclipse, that would be a much worse situation. So being eclipsed is really bad. That does introduce the torsional strain. So this is actually going to be the 3rd most stable, or the 2nd worst rotational isomer here. Now, to continue, let's move that methyl group 1 more time. That's also going to move this hydrogen and this hydrogen, another 60 degrees, back into a staggered conformation. Now, with ethane, we jumped right to the staggered conformation, and we didn't have any extra nuance. But here, we can see that the methyl group is staggered along with the hydrogens. And that, of course, means that we don't have any of that torsional strain. So, no torsional strain. However, we can see that the methyl groups have gotten close together, and that is going to introduce a steric strain. So this is the one form that has quite a weird name that I would recommend putting to memory, which is Gauche. I believe just named after someone. So the Gauche conformation is staggered, it's stable for that way, but we do have that steric strain from the methyl groups, which makes it pretty good, but not the best. It would be better to put those methyl groups further apart, which makes it the 2nd best. Now, last but not least, or I guess you could say least, we're going to move these groups again, making them eclipsed, and now we're going to eclipse those 2 methyl groups. So we can see how that's going to look here. where our hydrogens are eclipsing, but these two methyl groups being together is pretty catastrophic. So this has, again, we do have that torsional strain because the bonds are eclipsing, or my apologies, we do have that torsional strain, but we have a really bad steric strain. This is the most unstable form because of that. These two methyl groups do not want to be near each other. And we're going to call this fully eclipsed. So we have partially eclipsed when the methyl groups aren't together, and fully eclipsed when the methyl groups are together. So all in all, let's look at these four structures again. Now clear up these arrows so we can make more sense of it. And you can see the four structures, their rankings, and their strain as well. So these are the four conformations of butane, and understanding the difference between torsional and steric strain can help us understand their stability. Now, we can do a graphical representation here as well, and I've pre-drawn it in as it's a little more complicated. But let's start again with the fully eclipsed Newman projection here, where our methyl groups are at 0 degree separation, they're eclipsing together. And this is the most unstable form at the highest energy. We move at 60 degrees, we get to the Gauche conformation, which is pretty good, but not the best. Another 60 degrees makes us less stable, eclipsing the bonds once again. But then we rotate a full 180 to get to the anti-staggered. And so instead of seeing that regular wave pattern that we saw with ethane, we see a much more complicated pattern emerge with butane. So those are the four Newman projections for butane.